So good morning. In our last class, we were discussing some of the important aspects of an electric dipole. We know that an electric dipole is a pair of equal and opposite charges separated by a small distance. So this is an electric dipole. It consists of a pair of equal and opposite charges separated by a small distance. With respect to this electric dipole, we need to define a quantity called electric dipole moment. Electric dipole moment is a vector quantity that points from minus q to plus q, and it is defined as the product of magnitude of either of charge on the dipole and the dipole length. If a dipole has charges of magnitude minus 1 coulomb and plus 1 microcoulomb. Minus 1 microcoulomb and plus 1 microcoulomb are the magnitude of charges on the dipole. And if the dipole length is say 1 centimeter, the dipole length is 1 centimeter, then what will be the electric dipole moment of this dipole? Electric dipole moment will be pointing from minus q to plus q, negative charge to positive charge, and its magnitude is equal to product of magnitude of either of the charges and the dipole length. ಎರಡರಾಗ ಯಾವಾದರೂ ಒಂದು ಚಾರ್ಜ್ ದ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ತಗೊಳ್ಳಿ. Say this one 1 into 10 power minus 6 coulomb into this is magnitude of either of charge into the dipole length is 1 centimeter. 1 into 10 to the power of minus 2 meter. So this will be 1 into 10 to the power of minus 8 coulomb meter. This will be the electric dipole moment. Electric dipole moment must be expressed in the units of coulomb meter. So this is regarding electric dipole moment. Also, I have told you the net charge on an electric dipole remains zero. Net charge on an electric dipole is zero. Minus 1 coulomb plus 1 coulomb will be equal to zero. But net electric field produced by dipole is not zero. An electric dipole is going to produce electric field at a point on the axial line of dipole or at a point on equatorial line of dipole. We know the expressions for electric field produced by an electric dipole at a point on the axial line and at a point on the equatorial line. See, electric field produced by an electric dipole at a point on axial line. Electric field produced by an electric dipole at a point on axial line. You know what is axial line? If this is an electric dipole, this is minus q, this is plus q. A line drawn along the axis of the dipole. A line drawn along the axis of a dipole is called axial line. So this is the axial line. This is point on the axial line. E point hatra, E dipole, electric field produced by the. And this point will be generally at a distance r from the center of the dipole. See, the distance of the point where electric field is measured is at a distance r from the center of the dipole. ಈ ಪಾಯಿಂಟ್ ಡಿಸ್ಟೆನ್ಸ್ ನ ನಾವು ಯಾವಾಗಲೂ ಡೈಪೋಲ್ ಸೆಂಟರ್ ಇಂದ ಮೆಜರ್ ಮಾಡಿರ್ತೀವಿ. r is the distance of the point p where electric field intensity is measured from the center of the dipole, right? ಈ ಪಾಯಿಂಟ್ ಅಂದ್ರೆ electric field ಎಷ್ಟಿರ್ತದೆ ಅಂತಂದ್ರೆ E action is equals to 1 by 4 pi epsilon naught 2p divided by r2, where p is electric dipole moment of this dipole. This is electric field at a point on the axial line of a dipole. See, we have even done a short dipole approximation. Now we will baritiradella electric field into a short dipole. This is for a short dipole. Now we problems barath pura short dipole mele bartave. So we are going to write electric field at a point on the axial line of a short dipole is 1 by 4 pi epsilon naught 2p divided by r cube. See, electric field produced by a point charge. Electric field due to a point charge. Electric field due to a point charge is E is equals to 1 by 4 pi epsilon naught q divided by r square. Electric field due to a point charge is inversely proportional to square of the distance. Electric field due to a point charge is inversely proportional to square of the distance. On the other hand, electric field due to a dipole is inversely proportional to cube of the distance. Electric field is inversely proportional to cube of the distance for a dipole. E proportionalities benefit. How does electric field due to a point charge depend upon distance? Electric field due to a point charge is inversely proportional to square of the distance. On the other hand, electric field due to an electric dipole at a point of axial line is inversely proportional to cube of the distance. So remember this equation: electric field due to a dipole at a point on its axis, which is at a distance r from its center, is 1 by 4 pi epsilon naught 2p divided by r cube. This is the electric field produced by an electric dipole at a point on its axial line. On the other hand, electric field produced by the same dipole, okay. Before we go for electric field intensity at a point on equatorial line of dipole, you must know what is the direction of electric field produced by the electric dipole at a point on the axial line. This point of the electric field magnitude, what is the magnitude of electric field at that point? 1 by 4 pi epsilon 2p by r cube. Which electric field is? We know that electric field is a vector quantity. Hagadre, what is the direction of electric field at this point? E point electric field, the direction is there. See, there are two electric fields acting at this point. E point electric field there are two electric fields acting at this point. One electric field is due to this plus Q. This plus Q will produce electric field at this point. Due to positive charge, electric field at a point will be radiating outwards. Due to positive charge, electric field at a point will be radiating outwards. We'll write it as E1. What is E1? E1 is electric field at point P due to plus Q. Next, there will be electric field at point P even due to this minus Q. Minus Q will also produce electric field at point P. What should be the direction of electric field at point P due to minus Q? Due to a negative charge, electric field must be pointing inwards. So this is E2. Now try to think which charge is close to point P. Whether plus Q is close to point P or minus Q is close to point P. How charge point P ke hatra ade nodri. We know that electric field due to a point charge is inversely proportional to square of the distance. More is the distance of the point, less will be the electric field. More is the distance between charge and the point, less is the electric field. Less is the distance between charge and the point, more is the electric field. Hagadre, plus Q has produced the electric field E1 at point P. Minus Q has produced the electric field E2 at point P. Can you tell me which among these two will be greater? E1 jasti irtada, E2 jasti irtada. E1 is produced by plus Q. E2 is produced by minus Q. Plus Q is close to point P. Minus Q is at large distance from point P. Which will be greater? Electric field E1 will be greater than E2. However, what is net electric field at point P? You said that there are two electric fields acting at point P, E1 and E2. What is the net electric field at point P? What is the net electric field at point P? Net electric field at point P is E1 plus E2 or E1 minus E2. What is the net electric field at point P? E1 plus E2 baribaka, E1 minus E2 baribaka andre, you must write E1 minus E2. Yakantandre, see at point P, both the electric fields are acting in opposite directions. Both the electric fields are acting in opposite directions. So E1 minus E2 is to be written. That is the net electric field. That is the net electric field. Hagadre, can you tell me what will be the direction of resultant electric field? What will be the direction of resultant electric field? Suppose two vectors, say A and B, are acting in opposite directions such that vector A is greater than vector B, or magnitude of vector A is greater than magnitude of vector B. What will be the direction of resultant vector? Whether the resultant vector will be in the direction of A or will be in the direction of B. Resultant vector ಯಾವ direction ಆಗಿರಬೇಕು? ಇದರ ಪ್ರಕಾರ ಹೇಳಿ. What should be the direction of the resultant vector? Whether the resultant vector should be in the direction of E1 or the resultant vector should be in the direction of E2. What should be the direction of the resultant vector, or what should be the direction of resultant electric field at point P? ಎರಡು electric field are E1 ಮತ್ತು E2. E1 and E2 are acting in opposite directions, so net electric field is E1 minus E2. ಹಾಗಾದ್ರೆ E1 minus E2 ಯಾವ direction ಆಗಿರಬೇಕು? what should be the direction of that E1 minus E2? What should be the direction of that E1 minus E2? Whether that E1 minus E2 should be in the direction of E1 or it should be in direction of E2. It should be in the direction of E1. Greater vector ಯಾವ ಕಡೆ ಇರುತ್ತೋ resultant vector ಕೂಡ ಅದೇ ಕಡೆ ಇರುತ್ತೆ. ಹಾಗಾದ್ರೆ this is net electric field at a point on the axial line. So this is the direction of electric field at a point on the axial line of dipole. ಹಾಗಾದ್ರೆ look at the direction of electric field, resultant electric field at a point on axial line of dipole and the direction of dipole. Look at the direction of electric field at a point on axial line of dipole and look at the direction of electric dipole moment. They both are in same direction, they both are acting in the same direction. Hagadre, what is the angle between electric dipole moment and electric field at a point on the axial line of dipole? What is the angle between electric dipole moment and electric field at a point on the axial line of dipole? What is the angle between them? What is the angle between them? What is the angle between them? 0. So, at a point on the axial line of dipole, electric field, resultant electric field at a point on axial line of dipole and electric dipole moment are parallel to each other. They both will be parallel to each other. Therefore, angle between E axial and P vector, E axial vector and P vector is 0 degree. The angle between electric field at a point on axial line of dipole and the direction of dipole moment will be 0. They will be parallel to each other, right? So this is regarding electric field at a point on the axial line of dipole. Now, if we look at the electric field at point on the equatorial line of a dipole, I have told you what is an equatorial line. A line drawn perpendicular to dipole axis. A line drawn perpendicular to dipole axis from its center is called as equatorial line. Suppose if this is an electric dipole, this is minus q, this is plus q, and the distance between them is 2a. This is called dipole length. This is center of the dipole. We will call this O. Here is a point. Let the point be P. P is a point on the equatorial line of dipole at a distance r from the center of the dipole. At a distance r from the center of the dipole. Right? This is a point on the equatorial line of dipole at a distance r from the center of the dipole. Point P was again at a distance r on axial line. Point P is now again on distance again on equatorial line at a distance r from the center. Right? Point to the distance now change ಮಾಡ್ತಿಲ್ಲ axial ಮತ್ತು equatorial line ಮೇಲೆ. The distance of the point on axial line as well as on equatorial line is the same, right? But the positions are different. ಮುಂಚೆ axial line ಮೇಲೆ ಇತ್ತು, ಈಗ equatorial line ಮೇಲೆ ಅದು point. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ electric field ಎಷ್ಟಿರ್ತದೆ? What will be the electric field at a point on equatorial line of dipole ಅಂತಂದ್ರೆ electric field at a point on equatorial line of dipole is 1/4π0 P by R. Electric field at a point on the equatorial line of dipole is 1/4π0 P divided by R cube. Direction nodri hage. What is the direction of the electric field at a point on equatorial line of dipole? P represents electric dipole moment. R represents distance of point from the center of dipole. However, electric field at a point on equatorial line of dipole is also inversely proportional to cube of the distance. Due to positive charge, electric field at some point must be radially outwards. Due to positive charge, electric field at some point must be radially outwards. This is E1. Electric field at point P due to plus Q is radially outwards. Electric field at point P due to minus Q due to a negative charge, electric field must be radially inwards. We'll call this E2. We'll call this E2. Right? So electric field at point P due to plus Q is radially outward, whereas electric field at point P due to minus Q is radially inward. However, at this point, two electric fields are acting. One is E1 and the another is E2. This is E1, this is due to plus Q, and this is E2, this is due to minus Q. Resultant must be in this direction. This is the electric field at a point on the equatorial line of dipole. This is the direction of electric field at a point on the equatorial line of dipole. And we know that the direction of dipole moment will be from minus q to plus q. Direction of dipole moment is from minus q to plus q. This is direction of electric field intensity at a point on equatorial line of dipole. Can you decide what will be the angle between direction of electric field at a point on equatorial line of dipole and the electric dipole moment? Angle between equatorial and p vector. Yesterday 180 degree. It is equal to 180 degree. Correct, Allah? However, can we write angle between electric field at a point on equatorial line of dipole and electric dipole moment is 180 degree. Theta for equatorial and theta for equatorial and electric dipole moment is 180 degree. Andre, at a point on the equatorial line of dipole, the direction of electric dipole moment and the direction of electric field intensity will be anti-parallel to each other. They will be anti-parallel. Axial line mele electric field intensity and dipole moment will be parallel to each other. One direction agirtave. Equatorial line mele they both will be anti-parallel to each other. Electric field intensity and electric dipole moment, they both will be anti-parallel to each other. Right? So this is regarding electric field at a point on the equatorial line of dipole. See, electric field at a point on axial line of dipole was 1 by 4 pi epsilon naught 2p divided by r cube. On the other hand, electric field at a point on equatorial line of dipole is 1 by 4 pi epsilon p by r cube. Axial line ಮೇಲೆ 1 by 4 pi epsilon 2p by r cube ಇದೆ. Equatorial line ಮೇಲೆ 1 by epsilon naught p by r cube. ಹಾಗಾದ್ರೆ at what point does the electric dipole produce larger electric field? At what point the electric dipole is going to produce larger electric field? Whether it produces larger electric field at a point on axial line of dipole or it produces larger electric field at a point on equatorial line of dipole. Elli ಜಾಸ್ತಿ electric field produce ಮಾಡ್ತಿದೆ. See, electric field at point on axial line is 1 by 4 pi epsilon 2p by r. Electric field at a point on axial line or equatorial line of dipole is 1 by 4 pi epsilon p by r. So where does it produce larger electric field? Where does it produce larger electric field? See, electric field produced by dipole is larger at a point on axial line than at a point on equatorial line. If I can write this in this way, see here, E axial can be written as into hage into, we know what is 1 by 4 pi epsilon p by r. 1 by 4 pi epsilon p by r cube is equatorial. So electric field at a point on the axial line of dipole is 2 times the electric field at a point on the equatorial line of dipole. Equatorial line of dipole hatra ಎಷ್ಟು electric field ಇರ್ತದೋ axial line ಮೇಲೆ ಅದಕ್ಕೆ double electric field ಇರ್ತದೆ. If the electric field at point on equatorial line of dipole is 10 Newton per coulomb, the electric field produced by the same dipole at a point on the axial line is 20 Newton per coulomb. So electric field produced by an electric dipole at a point on axial line will be 2 times the electric field produced by the same dipole at a point on the equatorial line. Can you tell me what will be the angle between directions of electric field at a point on axial line and directions of electric field at a point on equatorial line? Direction of electric field at a point on axial line and direction of electric field at a point on equatorial line. Average madhya angle enti. I will try to write both the points in a same diagram. Axial and equatorial line. Eradu onde diagram hakki nodi. This is an electric dipole. This is a point on axial line of dipole. We write it as PA. The dipole length is 2a. This is -2. This is plus q, this is center of the dipole, this is equatorial line, this is point on equatorial line. At this point, plus q produces an electric field in this direction, we write it as E1, minus q produces electric field in this direction, we write it as E2. E1 will be greater than E2, so resultant electric field will be acting in this direction. This is E axial. This is E axial. At a point on equator line, plus q produces electric field radially outwards. This is E1. Minus q produces electric field radially inwards. This is E2. Resultant electric field will be like this. This is E equatorial. Electric dipole moment is from minus q to plus q. Now my question is, what is the angle between E axial and E equatorial? E axial and E equatorial are in opposite directions. So the angle between E axial and E equatorial will be 180 degrees. So vectorially I can write the same relationship as E axial vector is equals to minus 2E equatorial vector. Vector form brother, I have to write this negative sign. Negative sign indicates that the direction of electric field at a point on axial line and that on equatorial line are opposite. This must be chosen if the options are in terms of vectors. Vectors nalli 3 options choose ಮಾಡಬೇಕು. minus 2 times E equatorial. E axial is equals to minus 2 times E equatorial. ಮಾಮೂಲು ಬರೆ magnitudes ನ ಕೇಳಿದ್ರೆ E axial is equals to 2 times E equatorial, right? So this is regarding electric field at a point on axial line of dipole and at a point on equatorial line of dipole. I think this is clear. Electric field at a point on axial line and at a point on equatorial line. Idrag eradu ನೋಡಿ. This is dipole. This is point on axial line of dipole. This is point on equatorial line of dipole. PE point on equatorial line. PA point on axial line. Point P hatra ಎರಡು electric field, one due to plus q, another due to minus q. Point P hatra one due to plus q, another due to minus q. Is this clear? What is the relationship between electric field at a point on axial line and that point on equatorial line? Electric field at a point on axial line is 2 times electric field at a point on equatorial line of dipole. Clear? If it is clear, we can understand electric field at any point due to an electric dipole. Axial line ಮತ್ತು equatorial line ಮೇಲೆ ಇರೋ ಪಾಯಿಂಟ್ ಬಿಟ್ಟು ಎಲ್ಲನೇ ಇರಲಪ್ಪ ಪಾಯಿಂಟ್ somewhere between axial and equatorial line. If the point is somewhere between axial and point, is this the point on axial line? No. Is this the point on equatorial line? No. ಹಾಗಾದ್ರೆ ಈ ಪಾಯಿಂಟ್ ಹತ್ರ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರ್ತದೆ ಗೊತ್ತಿರಬೇಕಲ್ಲ. We should be knowing electric field at any point due to an electric dipole. That must be known. ಇದು ನಮಗೆ ಥಿಯರಿ ನಾಗಿಲ್ಲ. Electric field at a point, electric field at any point due to an electric dipole is not in theory, but that must be known to you. Electric field at any point due to a dipole. Electric field at any point due to a dipole. See, here we have an electric dipole. This is an electric dipole. Let this be minus 2 and let this be plus 2. 2a is the dipole. P vector is electric dipole moment. Electric dipole moment always points from minus q to plus q. Let this be the center of the dipole. O is the center of the dipole. Now what I do is I choose a point somewhere between axial and equatorial line, or I choose a point other than point on axial and on equatorial line, right? I choose some point here. Let P be a point. See, P is neither on axial line nor on equatorial line, correct? P gu illa, illi illa point. Illi idre axial line mela agodu, perpendicular illi idre equatorial line mela agodu. Point is not here, nor the point is here. The point is somewhere between them. This is the point. See, this is a line. This is a line that joins point P to the center of the dipole. Correct? This is a line that joins point P to the center of the dipole. And you can see that this line is making some angle with the direction of electric dipole moment. This is direction of electric dipole moment. This is the line. This line is making some angle with the direction of electric dipole moment. We'll write it as theta. We'll write it as theta. What is theta? That must be clear. Theta is the angle made by line joining point P to the center of the dipole with the direction of dipole moment. This is theta. ಹಾಗಾದ್ರೆ ಈ ಪಾಯಿಂಟ್ ಹತ್ರ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎಷ್ಟು ಇರ್ತದೆ ಅಂತಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ at any point due to a dipole is given by 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught P by R into square root of 3 cos square theta plus 1. Electric field at any point on a dipole is given by 1 by 4 pi epsilon naught P divided by R cube into square root of 3 cos square theta plus 1. Theta ಏನು ಗೊತ್ತು? Theta is the angle between line joining point P to the center of the dipole and the dipole moment. This is direction of dipole moment. This is line joining point P to the center. ಇವೆರಡರ ಮಧ್ಯೆ ಇರೋ angle theta. ಹಾಗಾದ್ರೆ ಇದೇ ಈಕ್ವೇಷನ್ ನಾವು ನೀವು ಥೀಟಾ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಆಕ್ಸಿಯಲ್ ಲೈನ್ ಕೂಡ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು. ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ರಿಮೆಂಬರ್ ದಿಸ್ ಈಕ್ವೇಷನ್. ಕ್ಯಾನ್ ಯು ಟೆಲ್ ಮಿ ವಾಟ್ ವಿಲ್ ಬಿ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಥೀಟಾ? ವಾಟ್ ವಿಲ್ ಬಿ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಥೀಟಾ if point is on the axial line? ಈ ಪಾಯಿಂಟ್ ಏನನ್ನ ಇಲ್ಲಿ axial line ಅಲ್ಲಿ ಇದ್ರೆ ಇಲ್ಲ ಇಲ್ಲಿ ಹೋಗ್ತದೆ. What will be the value of theta? If the same point is on the axial line, what will be the value of theta? What will be the value of theta? 0. Cos 0 is 1. Cos 0 is 1. 1 into 3 is 3. 3 plus 1, 4. Square root of 4 is 2. 2p by r2y. That is electric field at a point on axial line. What if the same point is on equatorial line? What will be the value of theta? What will be the value of theta? What will be the value of theta? 90 degree. If the point is on equatorial line, the value of theta will be 90 degrees. Cos 90 is 0. 0 into anything is 0. 0 plus 1 is 1. Square root of 1 is 1. 1 by 4 pi epsilon P by R cube is electric field at a point on equatorial line of dipole. So, suppose a point is at an angle of 60 degree with the dipole moment. Suppose the point is at an angle of 60 degree with the dipole moment. Theta 60 degree. Cos 60 is 1 by 2. Other square ಮಾಡಿದ್ರೆ 1 by 4 ಬರ್ತದೆ. You can further evaluate. So that is the expression for electric field at a point on electric field at any point due to an electric dipole. Electric field at any point due to an electric dipole. Right? So this is regarding electric field produced by an electric dipole at a point on axial line, at a point on equatorial line, and at a point at any point on the dipole. Right? So just remember these equations. This will help. ಇದಾದ್ಮೇಲೆ direction of electric field. See, if the point is on the axial line, electric field will be in the direction of dipole moment. Dipole moment ಯಾವ direction ಆಗಿರುತ್ತೋ electric field ಕೂಡ ಅದೇ direction ಆಗಿರುತ್ತೆ. Or we can say electric field at a point on axial line and electric dipole moment are parallel to each other. If the point is on equatorial line, electric field and electric dipole moment are anti-parallel. ಅವೆರಡರ ಮಧ್ಯೆ angle 180 degree ಇರುತ್ತೆ. ಇದು ಗೊತ್ತಲ್ಲ? ಹಾಗಾದ್ರೆ what if the point is somewhere between axial and equatorial? ಅವಾಗ direction of electric field ಏನು? What is the direction of electric field at any point due to a dipole? ಗೊತ್ತಿರಬೇಕಲ್ಲ? Axial line ಮೇಲೆ ಅಂದ್ರೆ electric field is in the same direction as that of dipole moment. At a point on equatorial line ಅಂದ್ರೆ electric field is opposite or anti-parallel to the direction of electric dipole moment. What is the direction of electric field at any point on the dipole? That must be known to us. ಅದನ್ನ ಹೇಗೆ ಮಾಡೋದು ನೋಡಿ. Suppose if this is a dipole, this is -2 and this is +2. This is center of the dipole. Let us suppose there is some point here where electric field is to be determined. This is line joining point P to the center of the dipole. This is angle between direction of dipole moment. This is the direction of dipole moment, and this is line joining center of dipole to point. Theta is the angle between dipole moment and the line joining center of dipole to point. Now, this point P, this vector P can be resolved. This vector P can be written here. I mean, vector P must act from -2 to +2. So I write it here. Now, this vector P is acting at some angle theta with this line. However, this vector P can be resolved into two components. This vector P can be resolved into two components: P cos theta and P sin theta. This vector P is resolved into two mutually perpendicular components: P cos theta and P sin theta. However, this is a component of electric dipole moment. P cos theta is a component of electric dipole moment. However, P cos theta ಗೆ ಈ ಪಾಯಿಂಟ್ axial point ಆಗ್ತದ, equatorial point ಆಗ್ತದ. P cos theta is a component of electric dipole moment. ಅಂದ್ರೆ ಇದು ಕೂಡ dipole moment ಇದ್ದಂಗೆ. It is a component of electric dipole moment. ಹಾಗಾದ್ರೆ point P for P cos theta will be a point on axial line or on the equatorial line. For the component P cos theta, point P will be a point on axial line or on the equatorial line. Axial line agala. Hagare, for this component, electric field at point P must be in same direction as this component. For this component, point P is the axial point. Point P is the axial point. Hagare, at a point on the axial line of dipole, electric field will be in the same direction as that of the dipole moment. Dipole moment ಯಾವ ಡೈರೆಕ್ಷನ್ ಆಗಿರುತ್ತೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕೂಡ ಅದೇ ಡೈರೆಕ್ಷನ್ ಆಗಿರುತ್ತೆ axial line ಮೇಲೆ. ಇದೊಂದು ಸ್ವಲ್ಪ ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ಅನ್ನಿಸ್ತದೆ ಕಾನ್ಸೆಪ್ಟ್. ನಾವು ಏನು ಮಾಡಿದ್ವಿ, ಡೈಪೋಲ್ ಮೊಮೆಂಟ್ ನ ರಿಸಾಲ್ವ್ ಮಾಡ್ಕೊಂಡ್ವಿ. P cos theta P sin theta ಅಂತ. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಒಂದು ಡೈಪೋಲ್ ಮೊಮೆಂಟ್ ಕಾಂಪೋನೆಂಟ್ ಬಂತು. ಅಂದ್ರೆ ಈ ಪಾಯಿಂಟ್ ಅಥವಾ ಈ ಪಾರ್ಟ್ ನ ಕೂಡ ನೀವು ಒಂದು ಡೈಪೋಲ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. You can consider this part as an electric dipole whose dipole moment is P cos theta. This portion can be considered as an electric dipole whose dipole moment is P cos theta. ಹಾಗಾದ್ರೆ ಈ ಡೈಪೋಲ್ ಗೆ ಈ ಪಾಯಿಂಟ್ axial point ಅಂತ ಕಾಣಿಸ್ತದೆ. This point appears like axial point. At a point on axial line of dipole, electric field, direction of electric field will be same as dipole moment. Angle estirಬೇಕು ಹೇಳಿ. What should be the angle between electric field and dipole moment at a point on axial line? ಆ angle ಅದಕ್ಕೆ ನೆನಪಿಟ್ಕೊಳ್ಳಿ ಅಂತ ಹೇಳಿರೋದು. ಇಲ್ಲಿ ಒಂದು ಸ್ವಲ್ಪ ಕಾಂಪ್ಲಿಕೇಟ್ ಆಗ್ತದೆ ನೋಡಿ 0 ಆಯ್ತಾ. ಈ ಕಾಂಪೋನೆಂಟ್ for this component P sin theta, for this component P sin theta ನೀವೇನು ಮಾಡಬಹುದು ಗೊತ್ತಾ, ಇಲ್ಲಿ ಒಂದು ಡೈಪೋಲ್ ಅದ ಅಂತ ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೊಳ್ಳಿ. Can imagine a dipole here. For this component P sin theta, ಈ ಪಾಯಿಂಟ್ axial line ಮೇಲೆ ಅದ equatorial line ಮೇಲೆ ಅದ. For this component P sin theta, this point P is on axial line or on the equatorial line. इधर मुगिತು P sin theta component ಕೆಲಸ ಮುಗಿತು. P cos theta ಮುಗಿತು. P sin theta ಆಲೋಚನೆ ಮಾಡ್ರಿ. P sin theta, for this component P sin theta, point P appears to be on the equatorial line, and we know what is the direction of electric field at a point on equatorial line. Electric field is anti-parallel to the direction of dipole moment at a point on equatorial line. ಹಾಗಾದ್ರೆ ಇದಕ್ಕೆ anti-parallel ಇಲ್ಲಿ ಹಾಕ್ತಾರೆ. This is ಈ equatorial direction. ಇದಕ್ಕೆ exact anti-parallel. ಹಾಗಾದ್ರೆ ನೋಡಿ ಈ ಪಾಯಿಂಟ್ ಹತ್ರ ಮತ್ತೆ ಎರಡು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಆಕ್ಟ್ ಆಗ್ತದೆ. One P axial and another P equatorial. E resultant will be somewhere here. E resultant. This is the direction of resultant electric field at any point on the diagram. This is the direction of resultant electric field at any point on the diagram. ಈ ಡೈರೆಕ್ಷನ್ ಏನು ಮಾಡ್ತಿದೆ, like suppose this direction is making an angle alpha with axial line. or let us suppose this resultant is making an angle alpha with E axial. We have a relationship. It can be proved that tan alpha is equals to half tan theta. Alpha is what is the angle made by resultant vector with the axial vector. What is the angle made by resultant vector with the axial vector alpha? Alpha hat find out what we have a relationship. Tan alpha is equals to half tan theta. Tan alpha is equals to half tan theta. What is theta? Theta is the angle made by line joining point P to the center with the dipole moment. If theta goes right, alpha find out what. If you know the value of theta, you'll be able to find the value of alpha. We'll be getting to know the direction of the resultant vector. We'll be getting to know the direction of the resultant vector. So, this is the formula that is to be used to find the direction of E vector. To find the direction of E vector at any point on dipole. At any point on dipole. ಒಂದು ಸ್ವಲ್ಪ ಇವಾಗ ಆಲೋಚನೆ ಮಾಡಿ ನೋಡ್ರಿ. ಈ ಒಂದು ಸ್ವಲ್ಪ ಆಲೋಚನೆ ಮಾಡಿ ನೋಡ್ರಿ. What is theta if the point actually lies on axial line of dipole? What is theta if the point actually lies on axial line of dipole? Theta is what is theta if the point actually lies on axial line of dipole? Theta 0 tan 0 tan 0 tan 0 is 0 0 and anything is 0 tan alpha is 0 tan alpha is 0 means tan alpha is 0 tan alpha is 0 means alpha is 0 however the resultant vector does not make the resultant vector is parallel to the direction of electric dipole moment. What is the value of theta? What is the value of theta for the point on equatorial line? 90 degree. Tan 90 is undefined. Tan 90 is undefined. So, you will get the answer. So, you can generally make use of this formula to find electric field intensity at any point on the dipole, direction of electric field intensity at any point on the dipole, right? So this is regarding electric field at a point on electric field at any point on the dipole. Formula for finding out electric field at any point is 1 by 4 pi epsilon naught P by R cube into square root of 3 cos square theta plus 1. Direction of electric field at any point can be determined using the formula tan alpha is equals to 1 by 2 tan theta.